Hello everyone, in this video I will show you our new product, that is KinCony A32 Pro. And this controller we have designed almost takes 1 year. So we have added many new innovations in this board. And this board also made by ESP32, but this time we designed made by ESP32S3. So that have a big memory and have a more fast than before we have used. And this board also will support by Home Assistant by ESP Home, and you can write your Arduino code and also support the MicroPerson. So in this video, I will explain the hardware design details and how it works with the different firmware. For example, how it works with the Home Assistant by ESP Home, and how it works in KCS firmware, how it works by Tuya application, and how it works with the voice control by the Alexa and the Google Home Speak. So let's first look at the hardware details. And let's look at my computer. You can see this is A32 Pro. And we will look at the total information about this box. So you can see this box appearance, and this is inside. And you can find every pin defined on this diagram. And later I will show you the new PCB board. And some details, aluminum shell, and you can see this time we have added this toggling switch button so that it can work without internet if the controller broken. So this manual control button is very important. And this time we have added this LCD SSD 1306 LCD that will support by ESP Home. So it's very easy configured to display your information. And you will see this IP address for the Ethernet and for the Wi-Fi. And also you can see this time we have designed for ESP32S3. So that have this version. So we use this memory size N6R8. And also we have used this Tuya module. So that is a Home Assistant and the Tuya can work at the same time. Because maybe you can remote control by internet by this Tuya application. And also you want to use the Home Assistant in your local network, in your private server. So that the internet broken, well, no problem. You can also use the Home Assistant. Okay, you can see the PCB in front and the back side of the PCB design. And this is, you can see the LED indicator for different relay and it's part installed on the DIN rail. And this you can see the Tuya mobile phone application. You can remote control by 5G, 4G, 3G or Wi-Fi. You can see at here, and 32 channel switch and 2 channel dimmer and 4 channel digital input state. You can use this one panel in Tuya application. And also you can see this have some technical information for the schematic, and because you can see we have designed this PCB board and we can have designed this schematic. And the schematic also is open source. We have uploaded to our KinCony's web page. You can see you can download the schematic at here, A32 Pro, and schematic at here, just software document. Okay. And also you can see this PCB we have designed. You can see the 3D mode, and it will be easy to see this. This have two sides, different components. When you see the PCB board, truly it's very beautiful. Okay, this is the hardware. And also you can see this have some ESP32 pin defined and config YAML file for ESP Home, and the Arduino source code and the KCS firmware. And you can see in our phone, so you can see that is ESP32 pin defined. Every pin defined of the hardware. Analog input and I2C bus and I2C relay GPIO and some dimmer and free GPIO 1.1. And the Ethernet, this time we have designed the Ethernet chip by W5500. And this IS485 and 4G module. And this is Tuya module. So, and RF remote. So this is very powerful hardware resource and back. And we can see this is for ESP Home. This is YAML file ESP Home for 40 channel digital input and 32 channel relay output and dimmer 0 to 10 volt output. You can connect with your motor, change the speed, or connect with your LED strip to change the brightness. And this analog input, you will see at here, 0 to 5 volt and 4 to 20 milliampere. So you can connect with a different analog sensor. And you can see this code for ESP Home YAML. You can just directly to use, and you can download it here. And also you will see that the Arduino source code for relay output and for input, and how to use IS485, and how to use the USB part for debug in Arduino IDE, and how to use the 4G module to debug AT command. So there are many different source code for you to use. So this is the hardware and the software document at here. Okay, now I will show you the hardware details. We can look at the inside of the box. Okay, let's look at this is our A32 Pro. This also use aluminum, the shell, and the back. That is a plastic shell. So that this box, you can see, it can easily install on the DIN rail. So we can easily install your power distribution box. And you can see this LCD display, and this is toggle switch. That is for manual control, but without software, without firmware. And you can see this is relay output, and this have label, every pin defined. You can see this label, and this have some buttons and the socket. That is for 433 megahertz, because if you install this receive module, so that you can use the remote, use this remote, or use this remote. You can run this signal to this controller, so that you can link your button to which channel relay output by FTDD command if you download the KCS firmware. And this is the Ethernet port and the USB-C interface. And you can see this have two antennas. One is for ESP32 and one is for 2 If you use the 4G module, you will see we will install the antenna at here. You will have the 3 antenna. And the next, this one is for the GPS antenna. And this one that you can see, that's 1, 2, 3, 4, 5, 6 until 40 digital input. Because maybe you will use the 32 for this 32 relay output for connect with a wall switch. And also you will have 8 channel of digital input connect with the sensor. And also you can see this have the power, and this A and B is RS485. And this is one where GPIO. You can connect with your temperature sensor or humidity sensor, just such as the DS18B20 temperature sensor. You can connect it here. And you will see that the DAC1 and DAC2, that is 1 to 10 volt output connect with dimmer, and this is analog input A1 to A4 for analog input. Okay, next I show you open this box and look at this inside of the box. And you can see this is our PCB, and remove this aluminum shell. And this aluminum shell you can see here, because this is the 4G version, so that have 3 antenna. And let's look at how this label print on the aluminum shell by the laser machine. Okay, now you have seen the laser machine how to print this label on the aluminum shell. So if you have all the many controllers, we can make OEM service that replace this logo for your company logo. So you can contact with us how to do this. And this is aluminum shoe. You can see that is the antenna. Let's look at this PCB board. And you can see at here that have two PCB board. This is for menu control button. So that LED screen. Okay, let's look at this PCB design of the back side. And you can see this quality. And this is ESP32 module. So you can see this time we have used the ESP32S3. And this N16R8 is the module of the ESP32S3. So this is big memory size. And this is Tuya. And this is in front. And you can see this time we have used this Ethernet chip W5500. So work for this Ethernet chip. And we have designed this Type-C, USB-C at here. And there have some different buttons. This is for Tuya reset, the Tuya information reset. And this is download button for ESP32. And this is reset for ESP32. And this is the relay output common and normal open every point. That is relay output terminal. And you will see this is our relay. This one, you can see that support max 7 ampere for AC load. And this is menu control button. And this is the 4G module, SIM7600. And I can remove this board. Okay. And you will see inside there are many chips. Because we have designed this digital input for long distance that support max 300 meters from your wall switch and from your digital dry contact sensor. So this is enough for you to use 300 meters. And also this is the power circuit. This power circuit. And this is the 4G module. If you buy this version have the 4G module, so we will install this 4G module. If you have ordered this version without 4G module, without this green PCB. And you will see the 4G module will have this antenna. This is for date. And you can see here that supports GPS. So this will have two antenna, and this module have two antenna. And you can see here, these two antenna will include because this is for ESP32 and for Tuya. And this one is for 4G module for this socket. And if you have installed a GPS antenna, for example, if you install this GPS antenna, just this one, GPS, so that you can use this hole. This hole is for backup, just for GPS use. You can install this IPX and SMA adapter at this hole. So you can use this IPX socket and connect with this GPS socket. Okay? So this is the hardware design details of our PCB board A32 Pro. Okay, now I will show you how it works with the different firmware such as the Home Assistant by ESP Home and the KCS firmware and used by the Tuya application and KinCony software. And first, we will look at how it works with the Home Assistant. And you can see I have connected with the power supply. And this is A32 Pro. And I will integrate to this. This is KinCony Server Mini. It's a Raspberry Pi computer. I have installed the Home Assistant at this box. So this time I will use the ESP Home integrate to this A32 Pro to this server. And I'm not installed the Wi-Fi antenna because I like use the Ethernet. You can see I have connected the Ethernet cable. And now I will connect with my DC-12 power supply. Just it here, and you can see This green is power LED, and you can see the Ethernet LED. Because I have already downloaded the firmware by the ESP Home, and you will see the LCD that should just print the A32 Pro, and you can print your all information by yourself. And you will see, you can see this is the manual control button. This without any software. You can see, even if I have disconnected the network cable, so that also can work. So this is physical without any software. So I connect with the Ethernet cable again, and I will open my Home Assistant dashboard. Let's open my Home Assistant dashboard, and you will see this is our dashboard that have integrated many different KinCony board in Home Assistant 1 account. And you can see, click here, A32 Pro, and you will see so many hardware resources that have the digital input and the relay output. And you will see, if I turn on all relay, and you will see this have turned on red and turn off. You will see the LED indicate on the relay box. And this is digital input. You will see, let's test the DI1, digital input 1, and digital input 2. And pay attention to my Home Assistant dashboard. And you can see this is ground, and this is digital input 1. So you can see, if I shut this ground to this input 1, and the Home Assistant dashboard that should on, and this is off. So you can connect with any dry contact sensor, such as door sensor, window sensor. You can see, just connect the digital input, this input 1, and this input 2, and this input 3. So you can just connect any dry contact sensor at here. And this is for the relay. And this one, you can connect with the DS18B20 temperature sensor, such as this one. You can connect with this sensor. You can see at here that W1 and W2. So that have two free GPIO for your use. And this is the power, 3 volt, because you can see if this DS18B20 temperature sensor need power. So this 3 volt, just this red line, you can connect with this 3.3 at here. And this is ground. This black is ground, just at here. This is ground. And this yellow is signal. You can connect with W1 or W2. So you can connect with two different sensors to this GPIO that's supported by ESP Home. Okay, this is DAC output, and you will see this dashboard DAC, that is output 0 to 10 volt, and you can see you can change the percent 66 and 86. You can connect with the motor speed or change your LED strip or change your lamp strip. So this mainly used for change speed and change the brightness. This have 2 channels for dimmer output. You can close it, and this you can see that's the analog input. Now I will test the analog signal input, and it will show in Home Assistant dashboard immediately. Okay, you can see I will use this one. This one is generate the voltage or the current. So that is just test for the different sensor, analog sensor, so that you can see this is output the current, and this output voltage. The A1 is voltage, A1, A2 is voltage, the A3, A4, that is current. So the first I can test with the voltage. So you can see that I can input 0 to 5. So I can close it because I will connect with the ground and the analog output. You can see the black is ground. And you can see my device analog output, the yellow to this A1 and this is ground. Just look at this, it's an analog sensor, 0 to 5 volt sensor. And open this, and you will see that default is 4.2 voltage. And look at my Home Assistant, and you will see that is 4.19. So it's very similar. You can see I can change it. I change it to 3.4 volt, and you will see 3.38, and this is the history. And even if you can see, I can change to 1.7, and you will see that is 1.65. And I can change to 4.5, and you will see 4.51. So this you can see the analog voltage input to this analog port. And then next we will test with the current output. We can change the cable to this one and change to A3 or A4 channel. Okay, now you can see I have changed the cable to A3. The A3 and A4 is the current input. So this time I have connected with this analog current output. So you can see, open this one and change the mode to this current. I can let it become smaller. 4.5 milliampere. And you will see in Home Assistant 4.35. Okay, you can see I can up 8.7, and you will see this 8.5. Because this can configure in ESP Home, so you can calibrate by yourself. And this is 14.3, and you will see the 14.19. It's almost a little difference. It's normal. So this is the current input of the sensor to the analog input port. Okay, you can see this is how it works with the Home Assistant, because you just configure your YAML file in ESP Home. So that will be very easy. You can see this is YAML file we have already prepared. You can download from our form. Just at here, you can just copy and paste from this one, this link. And then next, I will show you how to work with KCS firmware. That is KinCony Soup firmware. That is KCS. You can see that is this version. You can click and download the firmware on this link. And we will update some new firmware posted to our phone. You can download from our phone the newest. Okay, this time I will show you how to download the firmware. And you can see you can use the ESP download tool. Just use by this one. And use a USB cable and connect with your A32 Pro board and to your computer. And you can see the USB cable socket at here. So you can connect with it like this. And this part you will connect with your computer. Okay, now we can open this download tool. And this time the chip type, choose ESP32S3. And this load mode, choose the USB. And click OK. And at this window, you just click and choose your firmware bin file you have downloaded from our web page. And this address, just input 0 is OK. And this time you can choose the COM port for your computer. And you can click Start. So that will begin download the firmware to ESP32S3 chip. We just wait for a moment. And after it downloaded, you must reboot or repower on of your controller. And also you can press this ESP32 reset button. And this time, because I will use the Tuya application, so I will install the Wi-Fi antenna. So I can install these two antennas at the same time. Okay, and these two antennas. And I will repower on. You can see I disconnect the power and connect it again. Look at my LCD display, that will be changed. And wait for a moment, that have welcome information. Okay, you can see it will detect the Ethernet IP address and the Wi-Fi IP address. And the Tuya, because I have already configured the Tuya to my account. You can see the Tuya is online. And the Wi-Fi, I have, because the default is AP mode. If you have used STA mode, connect with load, and that will show the STA mode IP address. So this is Ethernet IP address, and this is the Wi-Fi IP address. So this is very easy to configure and login by the web browser. You can see I can use this IP address login in my web browser. Okay, now I have seen the IP address of the Ethernet. So I can just open a window and import the Ethernet IP address and enter. So that will be display the KCS firmware web page. It's very easy. You not need to use any scan device to find out this IP address. So the default is admin login. So that you can see this is the firmware, the index web page, and you will see the monitor. You can see that have the total device, the output, input device, and the sensor, and the dimmer, and the analog sensor state, and all different protocol state at here. The TUIA have already connected to the cloud server. So you can see I can click turn on and turn off. It's very easy. And all on and all off. So also you can rename by yourself. You can see if I rename to light, you can see, so that it's very easy, renamed. So you can click on and off and all on and all off. And this will show the input state. If I short for input, digital input 1, you will see it will be turn green. So you can see if I short this digital input 1 to ground, this will turn green. And short for the input 2, that will be turn green. Okay, and also you will see this analog output and the analog input. And next, I will show you how to use the TUIA. That will be very easy. We just use the TUIA mobile phone. You can remote control by internet. And you can see this is our TUIA mobile phone application. You can see I enter, and you will see the 32 channel switch and the dimmer. And you can see I can click turn on relay 1 and turn off relay 1. And also you can see the input state. I can put that here. If also I short the digital input 1, you can see digital input 1 and ground. And this one will be turn red. And this is second channel of digital input. And you will see that will be turn green. So this 4 channel will support remote monitor by the TUIA mobile phone. Because this TUIA is remote monitor by internet. And also this have a dimmer. And you can see this is a dimmer. I can change the different brightness. Just we'll let this output for different voltage. Let's test it. And you can see I use the multimeter to detect the voltage output. At here, and this is the ground, and this is DAC output 1. This is channel 1 of DAC output, and you will see if I change this brightness 3.3, you can see, and you will see my mobile phone 33%, and I change to 62%. That is 6.2 volt. It's very good. And I change to 76. You can see this is 7.57 voltage. If I change to 100%, you can see this is 10 volt. Very good. So this can change the different voltage output from this TUIA mobile phone. This is channel 1 and this is channel 2. So all used by the change the different voltage. And A32 Pro also support voice control. And you can see this is Alexa speak, and this is Google Home speak. That will support directly. And I can put that here. Okay, let's test it to work with Alexa. And this is TUIA application. Alexa, turn on switch 1.
Okay.
And you will see the switch 1 is on. This is feedback to the TUIA mobile phone. And this relay 1, switch 1. Alexa, turn off switch 1.
Okay.
Okay, you can see this is update. And also you can use Alexa mobile phone application. You can see this Alexa. So you can control by Alexa application, and this Alexa application also the update state between these two. So you can use this way. Also can use the Google Home Speak. I just not take the video of this demo for the Google Home. And because you can enable it, you can see click. You can enable this Alexa Speak and the Google Home Assistant. So that will support by the app directly. Okay, next I will show you how to use the wall switch. Because this A32 Pro, the digital input will support this momentary button, just a push button, and also support this launch switch. So in this video, I will show you how to work with different work mode, and I will take this video for this momentary switch. We can configure by different workway. And you can see this wall switch will be very easy. This is K1 to K6 because it's 4-channel. But for easiest demo, I will just use this K1 and K-com. This is ground. This LED for feedback, I'm not use it. We just use the simplest button, just this button 1. So I will connect this cable and K1 and K-com to this digital input and the ground. Okay, you can see I have connected this K1 and the K-com to this digital input 1 and ground. So you can see I press this button so that the digital input in my dashboard will be turned green. And this cable, you can see I just take a video, so this is very short. Actually, we have designed long distance, I have said. This cable will support max 300 meters, no problem. We have tested. Okay, just put it here. Okay, the next I will show you some most important option for relay output in different work mode. So we will look at what's different and will useful for different device, such as for motor, the interlock is very important, and for control the motor and control different device, we will use a different way. So you can see this input. The input is that just reverse options will be change the state. The high level is available or the low level is available. So this is for input, you can change this level. And this output, you will see there are some different work mode. So that will be used for the different load. So this is hold on. That means when you use mouse or use button, just click, that relay is on, and click again, the relay is off. So just hold on, the state will never change when your mouse pressed. So the default is hold on. So you can see I can click this monitor. If I click this that one, that is always on. Nothing changed. Unless I use my mouse to change it. You can click, that is off. So this is very easy to understand. And then the next, we will change the state. You can see the output. If I change the delay, that means it will auto off. So you can see if I press this 10, because that means 1 second. So that means the relay 1, because this is output 1, the total is 32 channel. So this is the relay 1. That means will auto off after 1 second. So you can see if I save it, click OK, it will be restart. Every time changed will be saved and reboot. And you will see, go to this monitor, and we can click this button 1. You can see, click on, and it will auto off after 1 second. Click on, auto off. I not use my hand to control the mouse. Just click, auto off. Okay, this is delay. So you can set different relay output for different delay time. So maybe you will need 2 seconds or 5 seconds, or maybe you need to auto off in half an hour. Always no problem. So this the hold on, and the delay is usually we used. It's very common used. And the next we look at the interlock. The interlock auto is very important for motor because such as your relay 1 and relay 2 can't all turn on at the same time because we need to protect the motor. Because if your relay 1 is on, your relay 2 must is off. Or your relay 2 is on, your relay 1 must is off. So it's very easy to set the interlock relationship with two relay. So you can, if you want relay 1 and relay 2 with this interlock, you can set the group to 1 and this also to 1. Just not set to 0. The 0 means disable the interlock function. So I want the relay 3 and relay 4 with another interlock group. So I can change to 2 and this is to 2. If I want 5 and 6 and interlock, I can change to 3. Change to 3. Okay, so you can see I can press save and we will test in our monitor. We can to turn on and turn off. Okay, we can click monitor and this time you can see I can turn on relay 1. Okay, no problem. But you can see pay attention to my relay 2. I can click. You can see this will out of relay 1 and then turn on relay 2. So this have set the relationship successfully with the relay 1 and relay 2. So you can see I can click relay 3 and I can click relay 4. You can see relay 3 will out of. So you can see I can, this will be work with interlock. Work with interlock. And this relay 6 and relay 5, you can see, also work with the interlock. So it's very easy. You just set these output options in different work group. So that will be interlock. If you want to cancel this interlock, you just set to 0. You can set to 0 and I can set to 0. That means I'll have disabled the interlock function. Okay, then I can press save and OK. And after some seconds will be reboot. Okay, reboot, I can go to the monitor and you can see this time I can refresh. You can see this time I can let this already work at the same time. Just cancel the interlock relationship. Okay, this is how to set the delay time and how to set the interlock in KCS firmware. And the next, I will show you the powerful function. And you can see the if TTT. So that will be very powerful. So if you want the input, just the switch work with the relay output, you just set the every different digital input with every different digital output. Okay, let's create the first if command. It's the simplest way. Just we will use your wall switch button. And this is a traditional switch. Oh, I have a quick demo for the monitoring switch. Let the input 1 work with the output 1. So you can create every different if command from the different input and link with different output. So you can see I can click edit. And the first one, I can change the name to rename to targeting relay 1. So I want input 1. The digital input, I can click this rising edge, just rising edge, press this button and apply, and then targeting relay 1, just input 1 is very easy, relay 1. So apply and enable this if command number 1. So I can press save. And after reboot, let's test in monitor. So this time you can see this is button 1. You can see I can press this button. The relay 1 is change the state. And this one you can see change the state. And also you can see my web page that will update the state. So you can see targeting relay 1, targeting relay 1. So this I have created the first if command. Let this button work with this relay 1. And you can create the second button with the second relay, and the third, and the 3, and the third are from the 3 and the 4 relay. So that will be very useful. Okay, this is how to create if command. Because you can use this if command to make many different automation. So you can choose if digital input is trigger or analog input is trigger or IF remote is pressed and the temperature is arrived or the time schedule is active. So that will send the different command by digital output, analog output, or this by this send short message, or make a call if you have the 4G module. And also you can see this can control the relay by the SMS short message or by the voice call by the GSM that need a SIM card. Okay, let's look at the most powerful function, the 4G module. If your board have this 4G module, so that you can use the 4G module with FTDD command. And you can see at here that we have a network web page. This have the Ethernet and the Wi-Fi, and here is the option of GSM. So if you have this 4G module, you can enable this option so that you can use the SMS, short message, and the voice call. And here you can set 6 administrator number for yourself. And at here you can see you can set the SMS control. That means you can receive what message, short message, will to trigger the FTD command action. For example, you can set turn on relay 1, or you can set turn on, turn off relay 2 by yourself. And also it supports your local language, not only English. You can use your native language. So you can custom define many different short message. This is for the FTDD command if condition at here. So you can create many, turn on relay 1, turn off relay 2. Maybe you can turn on pump or turn on motor, different short message. And this you can define the short message notification. For example, the sensor state changed will send a short message to your mobile phone. For example, the door is open. So just send some notification to your mobile phone by short message. So you can create many different short messages. This means the notification of the short message. And this is a call control. That means you can press your phone number and press such as 1. This means and must end for this character. For example, press 1, that is turn on relay 1, and press 2 is turn on relay 2. This need after press this number. For example, you have pressed this number and press this. This have connected. Then you can press 1. This one. This will turn on relay 1. This just used for FTD command if condition. So this differ many different number, 3 or 4 or 4. Just you can use a 3-bit, no problem. So this can, without edit any message, just press the number. So it's very easy to turn on and turn off some device. So this have some different short message and voice call to define, so that you can use in FTDD command. Such as if you have created the FTDD command, the digital input 1 is triggered. So you can click this one and set the short message is which one you have defined before, this short message 1, and send to which mobile phone number. You can define the 6th number of administrator before. So you can choose for this one. So that means for this FTD command, the digital input 1 is triggered, will both target this relay 1 and send a short message to the mobile phone number 1. So this is for the send short message notification. And if you want receive a short message and to turn on relay 1, so that you can do like this. SMS, when I received the short message control code, which one you have defined, and apply, and just target relay 1 or turn on relay 1. Just turn on relay 1 is this way. So this means when I received the short message 1, will turn on relay 1. So this is very flexible. Just use the if condition, so much condition, and link with this action command. So that if and then, if then. So you can create many automation. This is working locally without internet, without network. Just we work with the ESP32 chip locally. So this is powerful and it's stable for this board. So many resources you can configure by yourself. So this is an A32 Pro, a powerful board. You can use in Home Assistant, and also you can use it by KCS firmware for different automation projects. Okay, thanks for watching.